Hi, my name is Steve. Thank you for looking at my HalGuardian submission for the GDG Windsor Build with AI Gemma Hackathon. This was made by myself, and I am attributing also to my AI agent Hal, which is why he named it HalGuardian. So, HalGuardian is a proof of concept local first security assistant. It's running Google's Gemma 4 model through Ollama on this machine. It's analyzing code and untrusted input without sending any of your data to the cloud API. In this demo, you'll see some of these main modules in motion: Code Guardian, Trust Shield, Model Playground, Sub-Agent Control, Audit Engine, and Health. So let's start it up. We run the .bat, which opens up a terminal window, which launches the browser. So everything you see is running locally. The model endpoint is 127.0.0.1 on port 11.4.34. There are no API keys, no telemetry, and no remote inference by default. The audit entries, saved prompts, web fetch settings, and the whitelists are all persisted locally with SQLite and JSON-L files so that they survive application restarts. The architecture is straightforward. The front end is a Steamlit application, and the back end is a set of my Python modules that build prompts, call Ollama, parse responses, and log actions, and persist settings. The main pages map to those modules in order. So we have Code Guardian. That lets you review source code. Trust Shield lets you scan prompts and files. Model Playground is a free-form chat and model comparator that lets you compare how different models answer the same prompt, which is useful for choosing the best model for a specific job. The sub-agent console exposes every module as a callable command. Audit Engine shows the local logs, and Health shows environment settings. Settings is where you control the optional web fetch featuring, and the manual gives you explanations on everything, including how to add models of your own in order to run your own local models. So the application is built on a few simple rules. Inference stays local, audit logs stay local, and model output is never executed automatically, and the web fetch is disabled by default and gated by a whitelist and an explicit confirmation step. So fetched content is never passed to the model without your approval. Let's look at Code Guardian. Code Guardian lets you review source code, pasted text, or fetched web content. The module will read the file, select a system prompt based on the detected language, and send a structured request to Gemma 4. The model returns a markdown review, a lightweight parser extracts a verdict and summary table and individual findings. The full markdown response is always preserved for verification. In this example, we are going to review a file called badlogin.php. We upload the file, and Gemma, local model 4, is now locally reviewing. And here we go. So the verdict is, it needs changes. The summary table breaks down the findings into severity, testing, and complexity, and style. Each finding includes a severity line, reference, description, and recommendations. Let's watch the local model suggest the proper fix. The software doesn't write to your file system, so you can copy and paste the fix out into your own project. And here are the results. A full review can be exported as JSON or Markdown, so another script or agent can consume the structured result or the original Markdown. This is useful if you want to feed findings into a CI pipeline, a ticket system, or a secondary review process. Let's look at Trust Shield. Trust Shield helps you scan prompts, emails, documents, and web pages for signs of manipulative or hidden commands. It combines deterministic pattern matching with an optional deep scan from Gemma 4. The quick scan detects command language, meta instructions, and encoded payloads, such as base 64, hex, and URL encoded strings. It decodes the payload automatically. In this example, we are going to upload a suspicious file and choose our options, and we will choose a deep scan. Let's begin. This is the extracted text from the email. While we're waiting, we can see it has injection prompts. But we also notice that HalGuardian didn't execute them. So here are our findings. Again, exportable. So the deep scan sends the same input to Gemma 4 for a second opinion on intent, severity, confidence, and recommended action. Because it's a local call, the analysis adds latency but not exposure. Model Playground. The Model Playground is a free-form chat interface for any local Ollama model installed, like the conversation we're using with it right now, but with the model running entirely on your machine. The active model is selected from the sidebar, with the model running entirely on your machine. This is the model that CodeGuardian, Trust Shield, Model Playground, and Subagent are using. So we are going to load in a reasoning puzzle. And the reason for it is we're going to run the comparative feature while we're doing it. There are several different ones: SQL injectors, prompt injections, an intro from Gemma if you're interested, but again, the reasoning puzzle. So let's send this reasoning puzzle through, but we're going to send it through first to Gemma 3. Here we go. Oh, nice and quick. So in 6 steps, Gemma 3 solved the problem. It's a lot of text. You can pause and read it if you like, but we're going to go right to the compare. So we're going to now choose what to compare it with. Let's choose Gemma 4, and we can judge it with a model. And let's judge it with Gemma 4 as well. So let's compare the two. Gemma 4 is now going to answer the exact same prompt. And we can see the differences between the two. And then afterwards, we'll get Gemma 4 again to then compare the two and give us the analysis of the two different models. Here we go. So now we have the two models and the analytics between them, but now we can also open up their responses and view them together. We see 3.1, I don't think even answered the question, or pardon me, Gemma 3 and Gemma 4. Looks like they did. But let's confirm that. Now, let's have Gemma 4, that we chose as the judge, tell us the difference. Thank you, Gemma 4. AI comparison. We see that Model B performs significantly better. It successfully solves the puzzle, whereas Model A didn't even provide a solution. A valuable tool when comparing two models for which is better for your job. Now let's look at the subagent console. HalGuardian is designed to be called by another AL agent, not just to be used by a human in this environment. The subagent console exposes every module as a command that returns a standard JSON envelope. Each response has the same fields: OK, agent command, target, timestamp, duration in milliseconds, data, and error. This means your main AI agent can hand off work to HalGuardian. For example, before accepting generated code, the agent can call review code. Before fetching a URL, it can call scan. Before trusting a health report, it can call health. The project includes an agent prompt guide, that tells an external AI how to invoke HalGuardian with short, predictable commands. You do not need to write a long prompt yourself. Let's look at web fetch in action. We go to settings and make sure that web fetch is turned on. If it isn't turned on, CodeGuardian and Trust Shield do not have the web fetch active, and you will notice that a very large a very large message comes up explaining the security risks. But let's web fetch. If we fetch a URL, and I have on my website and as the default a broken code example, we can fetch that URL and look at it, and now it will detect it was Python and it will review it. Same findings as before. Needs changes. Trust Shield, same. We can fetch an injection page I have on my website. We can preview it. We can already see the encoding. And again, we can scan that input. Oops, pardon. And again, the findings. Lastly, the audit engine stores errors, good for troubleshooting. The health engine also shows the errors, but also ensures that your local model OLAMable is reachable and the persistent memory is active. So HalGuardian is a proof of concept, not a production security product. It demonstrates that local open models can provide code review, input classification, and audit logging, all while keeping data local and on the device. The source code and demo pages are available on GitHub. Thank you so much for looking at my video.